Principal sources of optimization. So in this video, we are going to learn about principal sources of optimization, which comes under the unit 5. So code optimization is the fifth phase of a compiler, which is used to improve the quality of the code. So quality in this context refers to the attributes that enhance the performance and efficiency of the executable code. So when you compile a high-level language, it will be converted into an intermediate representation, and then this intermediate representation is converted into a machine code. So there are a lot of redundancy will occur in the intermediate representation. So this redundancy will significantly reduces the performance of the computer. So therefore we need an optimizer to eliminate this kind of redundancies. So programmers are not aware of this kind of redundancies. So they cannot remove themselves. So therefore we need an optimizer. So here the quick start program, which contains 15 lines. So this code is converted into 30 lines of intermediate representation. So before converting this 3 address code into a machine code, we need to eliminate redundancies. So a principal source of optimization contain two techniques: semantic preservation transformation and loop optimization. Semantic preservation technique means so optimize the code without changing the functionality of the code. So here 4 techniques are available. First one is common sub-expression. An expression E is called a common sub-expression if E was previously computed. In this example, T6 is equal to 4 into I is the common sub-expression. So because the same expression is again computed in the third line, T7 equal to 4 into I. So here I value is never changed between the T6 and T7. So therefore, either we can eliminate T7 or T6. So therefore, the number of line is reduced as well as the memory size will be reduced. Next one is copy propagation. So U equal to V is the called as copy statement. So both U and V are same. So consider this example. So the temporary variable T3 is assigned to X. Next the X is assigned to array variable A of T4. So here X variable is not necessary. So directly we can assign temporary variable T3 to an array variable. So the memory size occupied by the X is removed. So therefore memory size will be reduced. Next one is dead code elimination. So we need to identify the dead code and eliminate the dead code in order to improve the efficiency of the compiler. A variable or a statement is live at a point if its value is used subsequently. Otherwise, it is said to be a dead code or dead variable. So here debug equal to false. So if the condition is false, print statement will be executed. Otherwise, print statement will not be executed. So in this point, there is in this there is no point. Debug equal to true. So therefore, if statement will never be true. So therefore, print statement will never be executed. So therefore, if statement is a dead code, we need to eliminate that if statement. Next, constant folding. So a value of an expression is a constant. We can directly eliminate that expression with a constant. So here 3.14157 divided by 2 is replaced by so the value of a constant folding, the value of an expression is a constant. So we can eliminate that expression with a constant. So 3.14157 divided by 2. So the result of this expression is 1.570. So we can directly eliminate that expression with 1.570. So therefore the computation of the expression is removed. That is different operation is eliminated. So therefore computation time is reduced. So therefore the quality of the code is improved. Next one is loop optimization. So here the number of code inside a loop is optimized. So inside a loop or outside a loop, a group of statement is removed from the loop is said to be a loop optimization. So there are three techniques available in loop optimization: code motion, induction variable elimination, reduction in strength. So first one is code motion, which decreases the amount of code in a loop is called code motion. So this transformation takes an expression which yields the same result irrespective of the number of times the loop is executed. So this is called as loop invariant computations. We need to move that loop invariant computation outside of the loop. So if a while statement is executed for 10 times, then the limit minus 2 will also be computed for the 10 times. So the limit minus 2 is the loop invariant computation. So we need to move that limit minus 2 statement outside of the loop and it assigned to temporary variable t, and then this t is used inside the loop. So therefore the computation time is reduced. Next, induction variable and strength, reduction in strength. So find induction variable in loops and optimize their computation, or else you can eliminate that induction variable. A variable x is said to be an induction variable if there is a positive or negative constant c such that each time x is assigned, its value increases by or decreases by c. So in this example, the block 2 contains induction variable. So that is I equal to I plus 1, T2 equal to 4 into I. So I and T2 are the induction variables, because if I is increased by 1, then T2 is also increased by 4. So we can move that code outside of that block, or else we can eliminate. So next one is we can reduce the strength of that instruction. So reduction in strength means an expensive operation is replaced with cheaper operation. So here the multiplication operation is the expensive operation, which is replaced with the cheaper operation addition. So T2 equal to 4 into I. So every time the T2 value is increased by 4. So the same statement can be replaced with T2 equal to T2 plus 4. So both are same, but the strength of the expression is reduced. So this is called as reduction in strength. So when we compile a program, first it compiled a high level language into an intermediate representation, and then this intermediate representation is converted into a machine code. So before converting the intermediate representation into a machine code, we need to optimize the code in order to improve the performance of the compiler, performance of the executable code. So we have a lot of optimizing techniques are available. So using that optimization techniques, so we can decrease the size of the executable code and decrease the computation time of an executable code. So automatically performance of the executable code will be increased. So if you have any doubt, comment in the comment section. Thank you.